Hey 309 students, welcome to our second video. In this one, I'm going to show you how to take your DEMs and turn them into a Basin raster file. And so I'm showing you here the two NHD flow lines as well as the mosaic DEM that we created in the previous video. So if you need a reminder, we started with these two DEMs and mosaiced them together and then just changed the color symbology so that we could have our high points in red and our low points in blue. And so you can see the stream network kind of drawing over top of the DEMs here. I'm going to turn off these two original DEM source files just to save some computer memory as this is cranking through the Basin raster processing, as well as turn off the two NHD flow line layers just to give us a little bit more computing power and so that this video goes a little bit faster for you. Okay, so we're going to start with the mosaic DEM file. And the first thing we need to do is go under Spatial Analyst Tools and find the hydrology data, or the hydrology toolkit. And you'll see eventually we're going to use this Basin one. But before we can get there, we need to first fill the DEM so that we can basically get rid of any sort of imperfections or sinks in the digital elevation model that would prevent water from getting routed properly across the surface. So we'll input our mosaic DEM, and then we can create our output file. Remember, we're still working with raster files. Raster files in this case have a .tiff extension. So we need to make sure that we provide that extension when we're naming our new files. So this is going to be filled DEM. So I'll just call it that, filled DEM.tiff. And that's all we need to specify here. So if I hit OK, it should crank through. You'll see it's working to fill the DEM. And in a moment, we should get that showing up on our screen. And I don't know how long it'll take, so I don't know if I should bother pausing the recording or not, but let's just give it another moment and see what happens. But you'll know if this worked. Most of the time, the DEM looks exactly the same after it's been filled as it does when you begin, but there might be some small changes. So if for some reason this low number is sort of an artificially low point in the landscape that GIS thinks maybe is an error in the digital elevation model and water is going to get stuck there on its way out of the watershed, then it'll fill this in and bring it up to a higher elevation. So that's where you sort of want to start looking when you've done a filled DEM, just to see if this low value changes at all. All right, I'm going to pause the recording and I'll come back in a moment when this is done filling. All right, so we got it to work, and you'll notice that the low point is now higher than it was before we did the filling. So that means it thought at least one of these points that was on the low end before was not really a correct number, and it filled that so that we would have a low value now of 99 feet instead of as low as 30. So it just changed our range here. So I'm going to go ahead and change our symbology again so that we can once again have the blue points as our low values and the high points as red. So now we can kind of see our DEM a little bit easier here. And the next thing we need to do is create a flow direction raster. So that's going to help us figure out what direction water would be moving in each cell. And so we're going to specify the input raster, which is our filled DEM. And we're going to specify where we're going to save the file as well as give it a name. So here we can call that just flow direction and include the .tiff extension. Hit save, and that's all you need to do. Everything else that's here is correct. So I'm going to go ahead and hit OK and let that crank through. And again, I'll just pause the video until that's done. Okay, so it just created our flow direction file. So you can see basically if it worked properly, you should get 8 different numbers and colors that are coordinated to those numbers. And if I just flip over a moment to this website from Esri on how the flow direction tool works, you can kind of see how it's going from the elevation surface to coding of the flow of direction. And this is how you would basically interpret those different colors. And so in this case, the darker green is this number 2. So that means flow from this cell and all of these cells that have this dark number 2 is moving to, let's see, it looks like to the southeast, right? And so basically it would be routing flow down this direction until it hit a different number. And okay, now all of a sudden it's at 4. So that means that flow would be going south. And so then water would start to move in this direction. So that's how you can interpret that flow direction layer we just created. Okay, so the next thing that we need to do is begin our basin raster processing. So now we can open that basin tool, input our flow direction, and give our file a name and specify where we want to save it, basin.tiff. And you can go ahead and run that, and it'll make your basin raster. And once we're done with that, again, this is just going to make a raster file. And if you wanted to do any further processing with that raster file, it's actually easiest if you convert that from a raster to a polygon. And then you'll have a shape file that you'll be able to do all of the normal things that you're used to doing, like clip the DEMs to that specific watershed boundary, as well as any of the stream layers that you want to clip, so that you can basically get everything within that one boundary. So that's what we're going to do after we've created this basin raster file, is we'll then create a polygon from the raster layer. All right, I'm going to pause the recording again until this is done. So see you in a moment. Okay, so if your basin raster processing worked, you should see this kind of black and gray and light gray layers that shows up. And you'll see that mine has a low of 1 and a high as 1040. So that means it made 1,040 different basin raster shapes. And so each one of these different colors represents a different one of those raster files. And it gets a little bit messy around the edges because it doesn't know what's next to it. So it can't really create a full watershed boundary. So it's just looking at what's in those 2 original DMs that we mosaiced together and then created this basin layer from. But you can kind of see the Spring Creek watershed here, as well as the Spruce Creek watershed here. So those are some of the watersheds that we've been doing our work in. Half Moon Creek, where you guys have your monitoring equipment for our project, is out in the Spruce Creek watershed. And of course, Penn State's in the Spring Creek one, which I think you all know by now. Okay, so to go from our raster file to our shape file, we want to go find the conversion tools and do let's see, from raster to polygon. So raster to polygon. So we'll input our basin raster. And then we just need to specify where we want to save it. So go to your folder. And we can just call this basin poly. And you don't need to put the .shape extension. It'll do that automatically. Hit OK, and it'll crank through and make your basin polygons. All right, that didn't take very long at all. So you can see this raster to polygon went ahead and worked. So we got our little checkbox next to our hammer tool. And now we can just go ahead and change the symbology so that we can kind of see behind this basin polygon layer. So we'll change it to no color and give the borders an outline of maybe 4. And a color of black. Can go ahead and hit OK. And now you can see the shapes for each of the rasters that were created. All right, so we'll start working in the Spring Creek watershed in just a moment. So if you want to see us do some clipping and more data processing in that watershed, come back and see our next video.